My name is Johan Lundin. I'm come from a finance background here in Stockholm, where I worked as a stockbroker for many years. I've transitioned into the exciting world of developing digital tools for all types of companies. And in my quest to do this, I've partnered up with our dear friends at Fire Labs and Datrics. And we have completed a lot of exciting projects together in Sweden. And I'm excited to be
We don't hear you. Something probably happened with your connection. Oh, Johan.
And I'm back. Can you hear me now?
Yeah, we hear you. Yeah,
okay,
please go.
Good. Sorry, I was disappeared for a second. So yeah, and I'm excited to be the Swedish representation of both Fire Labs and now Datrics, the exciting machine learning AI venture, and see what we can accomplish together here in Stockholm.
Great, thanks for introduction. Okay, I will pass forward to our speaker, Volodymyr Sofinskyi. He is chief data scientist, so he will share a little bit. Yeah, please share a little bit about your background and present yourself.
Yeah, hello, my name is Volodymyr Sofinskyi, that's a Volod for short. I have quite extensive background in machine learning and in analytics and in data science in general. I've been working with finance for quite some time, and then I was one of the lead data scientists for big data science department in Ukrainian software development company. And basically, I was responsible for quite a few projects there. Many of them were related to retail. So I have some nice experience in applying machine learning algorithms and machine learning tool sets to retail in specific. Should we say hello to Ken as well?
Yeah, Ken, please also present yourself. So you have very extensive background in procurement management. Yeah, please share some of the sense a little bit about your previous background.
Certainly. Thanks for having me join the session today. Those of you that see me identified as Catherine Mazzrillo on the Zoom meeting, this is my wife's computer. We're all dealing with these at-home technical issues from time to time, so I'm utilizing her account today. As Helen indicated, yes, my name is Ken Mazzrillo, and I'm an American living just outside of Boston. Working with Datrics to try to introduce the product platform into the U.S. market, particularly U.S. retail and systems providers, to help share some of the benefits it offers. My background is both on the indirect and direct side of procurement, store operations, and integration of systems within various retail companies and retail solution providers going back to the early 90s.
Okay, so just a brief introduction about like Datrics and why we decided to schedule this webinar. So as one of the partners at Datrics, I understand well all problems that retail businesses face with while they are considering AI integration. So here we just want to discover more about business value and business challenges in retail industry. So I will pass words to Volodymyr, so he will share a little bit more about his previous background, but from tech perspective, share a little bit about challenges. What challenges could face with retail companies when they will be thinking about AI integration. Okay. Yeah. So I think.
Okay, thank you. So regarding like the main problems with retail, most of them are built on top of demand predictions. So when you are able to like figure out what and how much and when you're going to sell, you can optimize quite a few things. One of them is just like the budgeting. You can budget the sale. You can like create your P&Ls more appropriately. You can budget the advertisement. You can like figure out what's actually going to happen. But on top of demand prediction, there are additional like use cases you can do. So for example, inventory management. If you know how much you're going to sell, you can also like using data science figure out how much time it's going to take for you to get new goods delivered, and you can pretty much optimize your stock to never run out of items without like keeping excessive amounts in stock. The other one is like promotion campaign management. So if it's more related to e-commerce, because for promotion campaign management, you actually need to know your customers. It's slightly more difficult in like grocery stores, for example. But in retail, it's quite easy to like identify your customers, to segment them, to figure out which segments you actually have, and to target them with your promotions. So the other one that's built on top of demand forecasting is price optimization. Price is like usually one of the main predictors on the amount of sales you're going to have. And if you have a very robust demand prediction algorithm, you can like optimize your prices to either maximize the sales or maximize the profits, or take any combination of those. One of the things that's not built on top of demand prediction is product recommendation. That's more applicable to e-commerce as well. But basically, when person is basically going through your e-commerce site and adding products to the basket, you can give like really smart suggestions on what the person should add to the basket as well. Because usually that's just the product that sells the best, or the product that has the most margin, or something that's been in stock for quite some time and you're really interested in selling. But if you're actually interested in providing like most benefit to the customer and maximizing your profits, the proper smart recommendation for that for those are more applicable. And basically, data science allows you to do something that's not like directly related to retail. So for example, implement chatbots, allow people to look at like various analytics and just monetize your data in general, because most of the like retail stores, and especially e-commerce, you have access to, usually like you gather a lot of data, you have access to that data, but usually people don't know how to monetize that and how like bring value from that. And machine learning just is a beautiful tool that allows you to work with that quite nicely. So what technologies are usually used with that? That pretty much depends on your specific company, because some companies are small, right? And you would look for platforms that are like pretty much freemium, or for some tools that would allow you to optimize your processes like with minimum resource required, and usually with minimum knowledge required, because small companies cannot afford to hire their own like high tier analyst or data scientist or machine learning engineer. Bigger companies have their own usually like have their own analytics department, right? But analytics departments are quite often focusing on actually providing analytics and supporting like marketing team and supporting C-level management. So developing new algorithms and developing new models can be somewhat like difficult. And one more thing that the big enterprises are not too interested in is like the security, because most of the tools require you like to install the tool on your computer or allow the tool access to your data. And big companies are really cautious about the security, about the privacy, and they just don't want anyone to have access to their data for quite obvious reasons. What tools are usually used? I would say like most people start with open source, like Python, but that requires quite a bit of extensive like prior knowledge. Barrier for that is quite high. If it's something like that has a very low entrance barrier, it's usually quite it's pretty much expensive. But during the last few years, there has been like quite a nice surge in what we call data science platforms. Basically, platforms that democratize the data science, make it more approachable, make it easier for people without like technical knowledge to use. So basically, if you're a good subject matter expert, if you know your business and you know your data well, that's usually more than enough. And since those data science platforms try to cover as many like horizontal, so basically they are not fine-tuned and tailored to like vertical use cases. They cover a broad spectrum of those. They are usually like quite affordable. How good are we in time?
I think like Ken could proceed, yeah, and discover a little bit about his background, because he's not at all tech guy, so he has more like experience in retail as managing procurement departments. So could you share a little bit more about like typical problems that like such companies could face with based on your previous background, what like tools you were using, what challenges such companies could face?
Sure, absolutely. Merchandise inventory management is a challenge for retailers across the board, particularly when you're trying to leverage both the physical and an e-commerce business. There's a tremendous amount of planning that goes into managing your stock levels to bring together how many goods you're going to require for sales to your walk-in customers in your physical spaces. And now with the onset of the buy online, pick up in store process and curbside delivery, particularly in the post-pandemic era, there's a challenge to understand how much inventory demand will come from your online sales resources versus your physical resources. So there's challenges there to understand exactly how to stock appropriately and stock for what. For merchandising departments and marketing departments to work together to plan promotions, that may be more of an easy process because merchants know what they're bringing to market, and marketing knows how they want to solicit those goods. But they may not have a full connection to the operations component of their physical stores or even their distribution centers to know in the store environment how much traffic is in the stores, how many people are being drawn into the stores. Is your signage effective to draw folks into the stores? Your window displays? Is the placement of the product in the store accurate? You may have a very well executed inventory plan and sales strategy and pricing strategy for the goods you hope to sell, but if your store isn't attracting people into it, if there isn't enough staff to engage with those customers, and if the placement of the product isn't in a sufficient area of the store, you may find yourself trying to figure out what was and wasn't effective and how to improve the next time around.
Thanks for sharing, Johan. We are pleased to see you. Yeah,
happy to be seen.
Yeah, also international. Yeah, here like team US, Sweden, Ukraine. Glad.
Well, I kind of have a question. What's the customer journey? Say you're a small, medium-sized business in retail, and you say, well, this sounds very nice. I don't know anything about AI or ML. what do we do? What do you do as a potential customer? What's the journey like? What are the sort of prerequisites to get this thing going?
I think Volodymyr, you will be.
I was on mute, sorry. Yeah, so I would say main two prerequisites is like understanding you actually have a problem, what you're trying to solve, and having the data that is available, that is like required to solve that problem. So for example, you are saying I am overstocking, right? I'm spending too much money. That's just locked capital that's sitting in my stocks. What can you do with that? You can literally gather all your transactions and try to figure out how much stuff is going to sell, like on a daily basis or on a weekly basis or on a monthly basis. That depends like mainly on how your business performs. And the next thing to do is like figure out how long it takes for the purchase order to be delivered to store. And by like having those two, you can optimize your inventory management quite a bit. And if we're talking about like price optimization, it's the same. Like you need to have like transactions. You need to understand how people were actually affected by the changes of price, because machine learning too, it's like machine learning in general and data science, they are like beautiful tools that allow you to do a lot of things without actually a lot of prior knowledge on how to use them. You like in current days, you don't need to build your own models. You don't need to know linear algebra. You don't need to know like differential equations. You don't need to like even have an idea what's happening underneath. It's just like a beautiful black box. You feed some data in and you get some data out. And
that
then
sounds great.
Yes, but the problem is the models are usually as good or slightly worse as the data that go in. So if you don't have data, if for example you're interested, what will I sell, but you have only 3 months worth of data, you will not be able to calculate the seasonalities on those, like how hard, no matter how hard you try or how well you know the machine learning. And the person who has, let's say, 10 years worth of transactions, he will catch the seasonalities even with the subpar models or algorithms. The things I would suggest to do is, first of all, like try to figure out what specific items you're most interested in, because no matter if you're selling like 20 different SKUs or you're selling 15,000 different SKUs, there is like a small fraction of those that you are really interested in. So we had, for example, experience with a big construction materials retail company, and they were selling around 13,500 different SKUs, but around 400 of those SKUs were responsible for around 60% of revenue. And that's a very small fraction. And if you can concentrate on those and try to optimize those in the first place, you will optimize your sales, your stock, your prices in very significant way. So basically the Pareto rule holds here a lot. 20% of the effort gives you 80% of the result. 20% of the goods bring you 80% of the revenue. And
all right.
So where
do you usually pull the data from? Which I guess it's point of sale systems or different inventory management systems, and
that again depends. Some people are still using Excel. Okay, so
okay.
So we might pull that just like a flat text file or Excel file. Some people have a standalone dedicated databases that are like very easy to access. Some people have POS systems that are sometimes a bit more difficult. So the POS system might have its own internal database that's hard to extract data from, and even harder to input data back in. So for example, if you have your results, you need to put that back into your system. That sometimes is a big problem. So integration and data gathering is usually a bigger problem than building like the very basic algorithm and trying to understand if your data is good enough to be monetized.
That hits on great points across retailers, especially more tenured organizations. It's funny you mentioned Excel. Excel is the most widely utilized enterprise resource program in the entire world. Of course, that data comes from somewhere and only has so many capabilities when you're utilizing those spreadsheet functions. So it's a shame to see how many older, very well-respected brands are having great difficulty in these times. Of course, pandemic issues have accelerated those, but the reason they've accelerated those is largely because of some of the inabilities they have with having managed their inventory for many years. Companies generally recognize that they have data collection and analytic capabilities, but they rarely have the budgets to upgrade them or a common agreement upon which systems to use and what solutions, what questions it is that they want to solve for. You've got competing efforts between your merchants, your marketers, your finance department, all have a say in ultimately what system you bring in. And any one system that you bring in can take a tremendous amount of money, a tremendous amount of time. And if it's not executed properly, it can be absolutely devastating to the organization. Trust me, I've been in one of those. So having the ability to extract data that is relevant from individual systems and utilizing a system such as that from Datrics to understand the nuances of each component of each question you're trying to answer is really critical. And we see that with newer boutique and digitally native, easy for me to say, brands that are opening up retail stores. It's not just the newness that they bring to the merchandise that they're selling, but it's the understanding and the embracing of machine learning and data science and all of these different factors that adds to their success and growth.
Yeah, and it's funny that you mentioned it. Like a lot of people are in a lot of companies are using old systems that are very, very hard to integrate with. So the statistics is that around 20% or even less than 20% of experiments, machine learning and data science experiments go to production in the end. And in most cases, those are not the problems with the data itself. So the data is good. You can extract some value from the data, but implementing it and integrating it with your specific system might be too big of a challenge. So one of the most famous of those, I believe, is Netflix $1 Million Challenge. I'm not sure if you've heard about that, but Netflix hosted a challenge on Kaggle where people were competing in order to build a better film recommendation engine, right? So currently, if you watched a few movies, Netflix will recommend something else for you that potentially will be interesting. And the winning team built a very nice algorithm that was significantly better than what Netflix had implemented at the moment. They won the $1 million, but Netflix opted not to implement it because it was just not practically useful. Sometimes that is a very big problem, that all the data you have, it's hard to extract the data, it's hard to pre-process, it takes too long to for example, train your models, and basically the scalability and interactions between systems are the main culprit, not the quality of data itself.
And I guess along those lines, what are the output from the model? Do you continue on the automation train there, or does it just spit out? Okay, we're low on the size 42 sneakers, or can you connect that to the actual wholesaler to order more? Or
so that depends on your specific system a lot. Because making, for example, a machine learning model that will give you alerts is not hard. Sometimes it might be okay, let me give you an example. We had, again, the same construction materials retail company, right? They had a very old POS and replenishment management system that it was built on COBOL. And it was like ancient is a very, very mild word to use. So what we needed to do is we extracted all the data pretty much in CSV files. That was a pain in the back to do. We pre-processed all the data, we trained the models, and then when we needed to put the data back into the system itself, that could only be done during the weekends when nothing was being sold, and the engineers who knew their system were taking the flat files back from us and literally like manually pushing them into the old system. And there was no database we could connect to. The system didn't have any API connectivity. It was just too old. So that was a bit of a hassle. At the same time, the algorithms were providing very good results. So it was worth it. And the model, in parallel, the model was running on the API that was literally sending you messages when you were about to run out of goods. So the replenishment managers didn't need to go through every specific item, through every specific store, and figure out if the model value that suggests how much you're going to sell within the next lead time window is higher than your remaining stock, right? You just had an email, hey, this specific branch is running of these 3 SKUs, consider like ordering them. So models can output whatever you want them to output. Usually it's hard to integrate. If you don't mind like having the email or some message sent, it's easy to integrate. If you want your messages sent through your system, sometimes it might not be feasible because you're just using too old of a system. If you're using Excel, it's going to be difficult because you're going to need to start writing VBA scripts to incorporate like the additional data that comes from machine learning.
When you talk about those emails, yeah, exception reporting is probably one of those things that causes everybody to run to the medicine cabinet, but it's necessary. The more predictability within your systems based upon past history and accuracy of data and incorporation of data from the different resources, your distribution center stock as well as your store stock, your suppliers open to sell stock, you're open to buy budget, accuracy and interaction with your inventory control teams to make sure that the inventory on the shelf data is accurate. These are all highly important. The more proactive you could be in those components, the more robust the data obviously is. But even where you have gaps in that data, which everybody has gaps in their data, having more predictability and a greater understanding as to what to bring in and when, or in the reverse, what to start marking down and when, to understand when stock is getting a little stale. These are massively important to any retailer, any commercial environment that sells anything, to know the flow of their goods and the cost of the inventory on their shelves.
That's true. That's true. And like at the same time, it's not always necessary to have like some state of art or rocket science level of machine learning. Usually, having like nice analytics and very simple like forecasts is more than enough for a good professional to understand what to do next. It just helps you do those informed decisions instead of just feeling like trusting your gut, right?
Of course, having the visibility into those different data points and the flexibility to work with your colleagues within the organization to make decisions on that on a common platform or an agreeable platform is important. You'll have a distribution center that works off a warehouse management system. You'll have a store operations team that's working off a POS system. Maybe they have some analytics data. You have a marketing team that are dissecting bits of information from all sources and probably has great access to e-commerce behavior that may or may not be reflective of the experience in the store. So being able to dissect these data points, yes, it can be very complicated and cumbersome, but it can also be brought down to very simple levels to satisfy your immediate need. So the complexity is really what you make of it. And the last thing anybody wants to do is create a system that is so overwhelming that they can't digest the data that they're collecting.
Yeah, so like the thing with machine learning is it should make your life easier, and it should take like the routine tasks away from you. So for example, building the plots of what were the historical sales and what might be the potential sales is something that can be handled easily with machine learning. Like the decisions on how much to reorder and at what point of time is feasible, but slightly more difficult, right? And for example, talking to the branch manager and explaining why you did some decision, that's not what the model can do. So it just needs to, like, the machine learning enhances people performance a lot, but by taking like the routine tasks or tasks that are just like computationally impossible for you to hold in your head.
All right.
And interesting, like, fact that during registration process we got lots of questions related to COVID crisis. What do you think? How will it affect like the retail industry? So will companies, retail companies will invest more in AI automation?
I believe retail is investing a lot already. Retail is top one investor into machine learning, like worldwide. And they are like closely followed by finance industry, but they are top one. Will they put more? Yes, because a lot of retail will switch to either e-commerce or mixed one. So for example, one that Ken already mentioned, when you can order online and pick up in store right away, right? At the same time, quite a few. So we had a customer who had this problem. Basically, they built their e-commerce as a standalone solution to their retail, and then they try to unite it. So for example, a person might be like, hey, I want to order this stuff and pick it up in 2 hours. You come to the store in 2 hours and the item is not there because the systems are not synchronized. So I believe retailers will expand their e-commerce presence quite a lot and will try to make it like as a one full business instead of like having a separate, like totally independent e-commerce and like physical retail parts.
I was on another webinar about a week and a half ago. A CEO made a very interesting point that he has seen the expectations of the growth of his e-commerce business expand to a 5-year plan over 3 months, where they had expected to be in terms of percentage of sales over e-commerce versus physical retail exploded in the course of the pandemic for the obvious reasons. But the anticipation is that a high percentage of that customer activity and sales will remain on the e-commerce side of things, simply because people are getting more used to the technology and the availability of it. People that were hesitant to purchase via any type of delivery service previously, or just weren't familiar with it, or use strictly one format for their hard goods and soft goods purchases, and maybe their groceries from another, that behavior is all changing. This is going to have a massive impact on the planning for buyers, replenishers, and store operations people to determine what amount of inventory is actually going to go into a physical store, what size the stores are going to be, what to do with the stores that are of a certain size, and then obviously the inherent expense of that certain size and inventory load with the shift in customer attitude and behavior.
Yeah, thanks. And also we got lots of questions related to lots of like data sources. Yeah, that's like retail companies they could have, how they could consolidate. Yeah, between.
That depends on your specific use case. So right, if you have 2 separate systems, one of them is responsible for purchase orders and the other one is responsible for holding like the transaction history, you can just combine those data inside the machine learning like pipeline, and that's it. Sometimes you don't need to have this giant data lake that stores old data. In many cases, you can just extract the data you have, pre-process it, clean it, and start using it in your solution. So like it depends. The cleanliness of data is usually very important. So the sources of data, machine learning models usually like handle very nicely multiple amounts of sources. So you can have a source that predicts the weather. You can separately have your purchase history. You can separately have your transactions, the lead times, and just combining them within the algorithm itself.
Yeah, Johan, do you have any questions? Probably some additional.
No, right now I'm pretty intrigued about the possibilities. This is a pretty new field to me, but you know, I'm beginning to understand its significance and also its challenges.
Yeah, and it's not secret that like Volodymyr is working on data science platform. Just could you a little bit discover like problem that you're resolving for businesses? What value will Datrics bring for retail companies?
So like one of the biggest problems there is, in my opinion, is this very difficult transition from experiment stage to production stage. Because usually, for example, for the experiment stage, you extracted the data in CSV formats, ran a couple of Jupyter notebooks, did some plots, for example, or extracted the data as an Excel again, and that's it. You're happy with what you have. Then you're like, okay, I need to run this on a weekly basis against my production data, and that might be a big problem because, for one, is its scalability. Sometimes the algorithms you've written will just not work on your full production data set. The second one is integration. So for example, if you uploaded the CSVs to the algorithm, that's good, but your data might change on a daily basis, right? And you will not have just enough time, and it'll require a tremendous amount of effort to do everything manually. And some systems might be very tricky to integrate with. And usually the hardest thing is to integrate the results back into your system. So uploading what the model is predicting and what the outcomes are into the system so the end users can use that. What we're trying to solve is we're trying to build the platform that allows you to experiment and productionalize at the same time. You can easily, so for example, you had data in files formats, right? Now you want to use the database. You just change one piece of the whole pipeline, which is like the data connector itself, and everything else remains. Like the missing values treatment remains, the outliers treatment remains, all the encodings, all the data pre-processing and the cleanup, it still works, and the model trains and everything works well. Or you want to do the final thing. So for example, instead of creating the plots manually, you can create like a very nice virtual dashboard that is automatically updated by the scheduler. And basically what we are doing, we're doing two things. We are enabling non-practitioners to work with data science in an easy way. And we are allowing practitioners to basically avoid MLOps works. That's like machine learning operationalization. You can just use your experiments and they will automatically scale up and work properly with any amounts of data, and will quite easily integrate into your system, be it through APIs that are again automatically created, or be it through database connections if you want that, or the interactive dashboards, or just flat files extraction that you can reuse manually on your own.
Yeah, and could you discover a little bit more about like use cases that you are like covering right now in retail?
Yeah, so currently for retail, we have a demand prediction use case, and we are planning to expand that quite a bit. So after the demand prediction, we plan to go with the inventory optimization, with price optimization, and with product recommendation. Those are the nearest use cases we plan to have already pre-built on the as pipelines on the platform, and you can just like upload your data, maybe change the cleaning and pre-processing part a bit, and use the models. So currently, for example, in our demand prediction pipeline, you can see that there are, for example, two different models. The reason for that is for our specific sample data set, one of the models is strictly better than the other. You can compare them by the metrics that are being provided, but that is not necessarily the case for every specific industry or use case. So we intentionally remained like let two models be there, so every user can compare and decide which model is better for him specifically.
As I'm listening to the conversation, having been a retail replenishment buyer, I know that when I was purchasing general goods, I often had multiple vendors that I could procure items from, and maybe at different quantity levels that were available to buy, varying price points that were available to buy, which of course affected inventory and margin. What processes would need to take place in order to understand availability from different suppliers, or to do comparatives of information from different suppliers about lead time, pricing, inventory?
So regarding the lead time, I believe the best thing to do is just to use the historical data, right? You can pretty much, again, create a separate standalone little model that will figure out how much time it will lead for this specific vendor to deliver this specific SKU to this specific branch. When you're talking about which vendor you should order from, that's the thing that's not like that straightforward, because sometimes you might have a discount on the delivery if you order a lot. Sometimes you might have like the minimum required quantity to be ordered from a cheaper vendor, right? And those are not too straightforward. So most likely you will need to try to build your own pipeline and try to like optimize what actually you're trying to do. If you know the delivery costs, if you know the for example minimum order quantities that needs to be incorporated into the algorithm.
So set factors are easy to predict.
Yes.
Variable factors obviously require a lot more detail work.
Yes, exactly.
Great. And I'm super happy that we have such interactive discussions, things like typical webinar, and supposed to arrange such probably interactive discussions on a monthly basis. And we'll be pleased to have more like people from business to hear their real problems. And understand more about their challenges. So we are done. So it's like 45 minutes of our interactive discussion. If you have something to add, you're welcome. We have something to add. Sorry. We've got around like 50 questions, so I will try to cover them, and send to all our participants who registered to our webinar. We will send also video recording for them. People were exhausted of all these webinars. Now we have offline. Online live. We will definitely send a report and some answers to all their questions. There were lots of questions related to typical quotation for AI integration for retail. It's hard to answer yet what is typical price, or like the challenges related to AI integration, or tools, software, that you could recommend. What are key factors while we choosing? So we will prepare very like some like probably reports after our webinar, share with our participants. So happy to have you, and thanks Johan for joining us. saying.
Thanks, guys.
Yes,
Happy to be here.
You're welcome next time as well. Volodymyr, thanks for sharing your tech.
And like small update, not the update, small thing I consider you should do. There is a very nice original series from YouTube called The Age of AI. It's not like directly connected to retail. It's just a very nice explanation of what currently machine learning does. Machine learning is not like a silver bullet that will help every task you wanted to help with, but like understanding what actually machine learning is and how data science works might want you to consider if it actually can help you. So I would really encourage you to watch an episode or two of that series.
All right.
And
thank you very much
for your attention.
We will add a link to our report and send to all our participants. Thanks, guys. Yeah.
Thank you.
Thanks for joining us. See you
Thank
next
you,
time.
everyone.
See you.
Take care. Thank you very
Bye.
much.